Figure 10.1 PolymorphismTest.java. This example uses the final versions of the Commission Employee and Base Plus Commission Employee classes that we looked at in the last lesson. However, in this case, what we're going to focus on is the ISA relationship that is created when we have class Base Plus Commission Employee inherit from class Commission Employee, whereas in the last lesson we were focusing primarily on the concept of software reuse, where we were inheriting a bunch of attributes and behaviors from an existing class to help us create a new class. Now, to get us started in this example, we are working with the Commission Employee 3 and the Base Plus Commission Employee 4 classes from the last version of the hierarchy, and you can see in the folder here with our polymorphismTest.java file that we do have the .java files for each of these classes. And just to reiterate, class Commission Employee 3 is where we define the information about a commission employee, and class Base Plus Commission Employee 4, as you can see here, extends Commission Employee 3 and adds a little bit more data, the base salary. Now, those classes are identical to the last versions we looked at in the prior lesson. So here what we do is we start by creating a couple of objects. We build a Commission Employee 3 object for the Commission Employee Sue Jones, and we call it Commission Employee. We also create a Base Plus Commission Employee 4 object for Bob Lewis, and we call this one Base Plus Commission Employee. Now, we're going to focus on these printouts here at lines 19 through 27 next. In lines 19 through 21, we have a printf statement where we want to output the string representation of our commission employee. And as you can see here, we use the commission employee variable to invoke the toString method and output this in a string format. Now, if you look carefully at the declaration here on line 10, we can see that Commission Employee is a variable of type Commission Employee 3. We can also see that the variable is aimed at a new Commission Employee 3 object. So we have a Commission Employee 3 variable that is assigned a new Commission Employee 3 object. We can say that that variable points to or refers to that object. And in particular, you can also say that we have a superclass reference to a superclass object. So the type of the object matches the type of the variable that we're using to refer to it. So when we use a superclass variable to refer to a superclass object, normally what you would expect out of that is any method you call is going to be for that superclass object. And in fact, when we do the toString representation of the commission employee, you will see that we do indeed get the string representation that we would expect. And in fact, if you look at the output here and compare the values that you see here with the values used to initialize the commission employee, you can see that indeed they are the correct ones. Now, when we come down a little bit further here and we take a look at the next printf statement, once again, we're using a variable to invoke a method. The variable we're using is the Base Plus Commission Employee variable, which, as you can see here, was declared to be of type Base Plus Commission Employee 4, and it's initialized with a new Base Plus Commission Employee 4 object. So I have a subclass variable that is aimed at a subclass object, and when I invoke a method on such an object, I expect the subclass method to be called. And if you take a look at the next chunk of the output here and compare the values that are being output for Bob Lewis and the string format that's being output, you can see that indeed these values on line 16 are being output here, and you know it's the base salary commission employee, the Base Plus Commission Employee being output because of the words that are coming out at the beginning here, and also the fact that we're displaying the base salary. Now, things get more interesting when you start to focus on the relationship between the classes in the hierarchy. In this case, we're declaring a Commission Employee 3 variable that is a superclass variable, and it's called Commission Employee 2 for the variable name. And that variable is being aimed at the same thing that Base Plus Commission Employee is aimed at. Well, from looking at the declarations up above, we know that this variable Base Plus Commission Employee is aimed at a Base Plus Commission Employee object, a subclass object. So what we have here is a superclass variable that is aimed at a subclass object. And the reason this assignment statement works, or this initialization works, is because of the fact that a base plus commission employee is a commission employee. Again, going to the base plus commission employee class, we said on line 6 here that base plus commission employee extends commission employee. Therefore, a base plus commission employee is a commission employee. And I'm using the names without the numbers here, but of course the class names are as you see in front of you on the screen here. So because of the is-a relationship, we're able to take a subclass variable and assign its value to a superclass variable as long as you go from the right side of the equal sign to the left side of the equal sign and go up the hierarchy, meaning towards the superclass, then this assignment or this initialization is going to be allowed. So again, a base plus commission employee is a commission employee. So not only is the compiler looking at this at compile time to help us determine if this is an allowed assignment, we also have some runtime specifics that are going on when this particular method call occurs. Now at compile time at line 34, all the compiler knows about are the types of the variables and what the definitions of those types are. The compiler knows nothing about objects in Java because objects in Java don't exist until we use the new keyword at runtime to create the objects dynamically. So all that the compiler can do when it sees this expression is look at the data type of this variable, which according to line 30 is commission employee 3, and then it can go look at that type to see if that type has a toString method that is called with no arguments, and that can be used to return a value, which in turn can be used in this continuing printf statement. So if we go back over to commission employee 3 and we scroll down to the bottom of the class here, you can see that indeed this class has a toString method that takes no parameters and returns in this case a string, which is what it's supposed to. So the compiler, when looking at this expression in the PolymorphismTest file, says yes, it is okay through a commission employee 3 variable to invoke a method called toString. But there's a very different thing that happens at runtime. At runtime in Java, the type of the object on which that method is being called determines the actual version of the method to be called. So when you look at this expression, commission employee 2.toString, and you compare it to what we did up here with commission employee.toString, you might expect that even though we're aiming the new variable at a base plus commission employee object, we're going to get the toString method from class commission employee 3. And actually that's not the case. What happens down here is that the type of the object we're referring to is a base plus commission employee 4, so that object's toString gets called as a result of line 34. And if you look at the bottom of our output here, you can see that even though we're invoking the method through a commission employee 3 variable, the base plus commission employee toString got called, and that's proven by the fact that we're starting by outputting base salaried, which only happens from the base plus commission employee toString method, and also the fact that the base salary is being displayed at the end here. So this is your first introduction to the concept of polymorphism. When you have a base class or a superclass variable that is aimed at a subclass or derived class object, what that enables you to do is perform some generic processing on that subclass object, where the concept of quote-unquote generic processing means only being able to invoke the functionality that was originally defined in the superclass or higher than the superclass in the hierarchy. So for example, one of our goals in this chapter is to expand this hierarchy of employee types to start with a superclass called employee with several different subclass types, and then what we want to do is create a payroll system where we can maintain a collection of employees, and regardless of whether they're commission employees, base plus commission employees, hourly employees, etc., it doesn't matter what type of employee it is. We want to be able to walk through that collection one at a time, knowing that every type of employee needs to get paid. And we want to calculate the earnings for every individual type of employee. And the key thing, the polymorphic aspect of that, is the fact that we can invoke that method exactly the same way regardless of what class we're looking at in the class hierarchy. If the base class, if the superclass defines a particular method as a public method, all of the subclasses are guaranteed to have that method, and all of those subclasses can then override or redefine that method to say how it should work whenever we happen to be processing an object of that subclass type. So again, we're going to focus on that polymorphic concept. Here we were showing you the basic assignment or initialization that enabled us to take a subclass object and assign it to a superclass variable, but still call the subclass functionality even when we use that superclass variable, and we will focus on that relationship in the remaining examples of this lesson as well.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.